Hi, everyone. I want to consider one more example to add to the section about inverse matrices and solving of matrix equations. So what I'm going to do, guys, I'm going to make up a system of two equations with two variables. Watch how I do this. I'm going to make up a system 3x plus 5y. Oh, my pen is too thick, I think. I'm going to raise this and just use a better one. Sorry. Let me choose correct thickness. So I'm going to create a system of equations with two equations. 3x plus 5y. I'm just taking it out of my head. And x minus 2y. Simple numbers. 3, 5, 1, 2. Now, guys, what I'm going to do, I want to know solutions of this system before I actually design it. So I'm going to set up, let choose x be equal to and y to be equal -1. Again, normally when you solve the problem in the book, you don't know x and y. But because I'm free to design any problem I want, I'm actually choosing certain x and certain y. Why? Well, because while I'm solving the problem, finding solution is not my goal. My goal is to show you how the method is working. So to show how the method is working, I want to make sure that you kind of have solution already to compare it to what we have at the very end. So we already know the solution. A solution is x equals 2, y equals -1. So if I plug it into my first equation, what I'm going to have, my 2, my 3 is 6, right? Minus 5 is going to give me 1. And here 2 minus -2 is going to give me 4. So I got a system of equations with like solutions which I set up ahead. Now, if I convert this system of equations into a matrix equation, how it's going to look? Well, let's start with writing down the matrix. Matrix is going to be what? 3, 5, x, sorry, not x, but 1, instead of x, sorry, 1 and -2. That's going to be my matrix. Column of unknowns is going to be x and y, right? And B column is going to be 1 and 4. Now, how my equation is going to look, how my system is going to look in matrix form. Well, first I'm going to write it with numbers, and then I'm going to write it generally. It's going to be 3, 5, 1 minus 2 multiplied by the column of x, y, and that's going to be equal to 1, 4. Basically, guys, this way to write down the system is equivalent to this way to write down the system. Why? Well, if you do standard matrix multiplication, it's 3 multiplied by x plus 5 multiplied by y is supposed to be equal 1, which is actually first equation. And then 1 multiplied by x minus 2 multiplied by y equals 4. That's exactly the same system, just in a different form. Now, if I kind of label this one as A, and this one as X, and this one as B, and A is going to be the matrix, X is going to be column of unknown, and B is going to be column of free part, I'm going to get equation in matrix form, which is going to look like AX equals B. If you forget for a second that A here is a matrix, and X here is a column, and B is a column, you're just going to see a normal equation, like linear equation, something what we see in algebra. Ax equals b, and x here is unknown. How do we solve this one? Well, we basically divide the right and left side by a, right, to find solution. Well, we can represent it as multiplying ax equals b by 1 over a, right, over here, and 1 over a over here. Here it cancels, and you have x, and here you are going to basically have b over a, which is you have over here. Well, how are we going to deal with matrix equation? Well, in matrix, we don't really have a division, but we do have inverse. Actually, kind of, this is 1 over a, is inverse of a, right? We remember that it's a to the -1. So what is inverse of matrix A? Well, we do know inverse. We know the rule how to find inverse, right? So what we can do a similar operation to this equation and multiply it. Instead of kind of dividing by A, we're going to multiply by inverse of A. So I'm going to do multiplication A, X equals B. I'm going to multiply by inverse of A. Inverse of A. Remember that matrices are sensitive to position of matrix. Here it does not matter. I multiply 1 over A here on the left and here on the right, and I still have correct solution. But with matrices, left multiplication and right multiplication are going to give you totally different results. So I'm multiplying on the same side, on the left. Here, guys, I remember that inverse matrix by direct matrix is going to be identity matrix. Here is going to be just like a product of matrix and the column, which is going to be another column, right? I know that identity matrix multiplied by X, I'm just copying the system. Identity matrix multiplied by X is same X, because identity matrix, the idea is that it's not changing anything. And I have X equals A inverse multiplied by B. So basically, if I do know inverse, if somebody gives me inverse, it's going to be very easy to find solution, which is X, which is going to be like XY. Just I'll need to multiply this inverse, which somebody gives me, or I kind of find it, by B column, which is 1, 4. And that's what I'm going to do. I'm going to use this method and check if my solution is going to match the one which I designed in the beginning. So let's see how it's going to work. How do we find inverse? Well, remember that inverse of the matrix is, well, maybe I should write down that general matrix first. Give me a second. So general matrix. It's going to look like A, B, C, D, right? What is going to be inverse of this matrix? First, it's 1 over AD minus BC. We're doing inverses only of 2 by 2 matrices. And then what we do here, we are exchanging A and D. I'm going to put D here and A here, exchanging A and D, and put minuses in front of B and C, minus B and minus C. That's basically going to be our inverse. Well, let's kind of use our matrix 3, 5, 1, minus 2 instead of A. So in our case, it's going to be what? 3, 5, 1, minus 2. And plug it in over here and see what we are going to have as inverse. It's 1 over AD. AD is going to be 3 minus 2. It's minus, I'm going to write down 3 by minus 2. And minus 5 by 1, right? And then I have to kind of switch diagonal elements and put minus in other elements. So 3 and minus 2 are going to be switched. So it's minus 2 and 3 here. And minus 5, I'm putting minus in front of B, and minus 1. So basically, guys, that's already my inverse matrix. I'm going to just multiply or kind of, simplify the denominator, and that's going to give me 1 over negative 11. And the matrix is minus 2, minus 5, minus 1, and 3. 1 over 11 is going to be kind of a coefficient. I'm not going to bring it into my matrix because actually it's going to be very complicated for me to deal with fractions. You remember, how do we bring in 1 over 11? We multiply every element of the matrix by 1 over 11. We are going to have 4 fractions over 11. I don't want to do this. I'm going to keep this as a coefficient, okay? You will see why. Now, because I do know inverse already, I'm just going to use this equation to find out x. So I'm going to write down my x, which is going to be equal. Remember that what x in the beginning was equal to this. X and y, actually my unknowns. And it's supposed to be A inverse multiplied by B. Well, I'm just going to copy my inverse. I'm going to start with coefficient 1 over 11. I put minus in front of the whole fraction, okay? And then minus 2, minus 5, minus 1, and 3. And what is my B? Well, my B is 1, 4. Remember my free part, 1, 4. Let me move this over here so it's not going to distract me. So now I'm just going to do multiplication. And I'm going to keep the coefficient, okay? You will see how it's going to disappear eventually. Remember how we multiply matrices? Yeah, this is a column, but it's just a very small matrix. We first take the first row and multiply it by the first column. So minus 2 by 1 is going to give us, well, I'm just going to write down minus 2 by 1 and minus 5 by 4, minus 5 by 4. We're not going to have more elements on this row just because there is no more columns. And then minus 1 by 1, minus 1 by 1, and 3 by 4, and 3 by 4. I'm going to simplify my very short matrix, minus 2, right? And minus 20. So it's minus 22. Here I have 12 minus 1, which is going to be minus 11. Now I'm ready to bring this fraction in. I'm going to multiply minus 22 by 1 over 11 and minus 11 over 1 over 11. What I'm going to have over here, 22 over 11 is going to give me 2, right? Minus and minus cancels, and I'm going to get 2. Here, 11 over 11 is going to give me 1, minus over minus is going to give me 1. Well, the only thing I think I put too many minuses. I should not put this minus. I don't know why did I put it over here. There is no minus here. And of course, I erased, besides minus, I also erased the 1. So again, because it was 12 minus 1, it's not minus 11, it's just 11, right? So I have over here 11 over 11, 1, and minus is going to stay in front. Doesn't look very nice. I'm going to read it and write it down one more time. Yes. And I'm going to have what? Over here, I'm going to get 2. And over here, I'm going to get just minus 1. So if I compare this and x and y, I'm going to make a conclusion from here that my x equals 2 and my y equals -1. Now I'm just going to look at this x and y and compare it to what I designed actually as a solution. And that's exactly the same. So you see, the matrix way gives you like very nice way to solve system of equations. The only one kind of narrow point here is that all inverses besides 2 by 2 are calculated in a more complicated way. 2 by 2 is just defined like this, and you calculate it like this, and just takes a minute, right? But if you need inverse 3 by 3 or 4 by 4, it's longer to calculate inverse. So of course, you probably will tell me, okay, why should I do this complicated inverse matrix multiplication instead of just kind of do elimination? Yeah, guys, elimination is faster here. For 2 by 2 systems, yes. And there are some systems for which you accidentally know inverse, and that's much easier to multiply inverse by the column instead of kind of solving elimination, right? Well, again, I'm trying to teach you different methods. I don't know which ones you will need in future. So it's not like you need to know just one, the fastest way. In some cases, fastest way is elimination. In some cases, fastest way is multiplication by inverse. You will need to know kind of different ways to solve the same problem. Okay, that's all about inverses. And I hope that you got the idea over here. So we basically are solving matrix equations. This is called matrix equation. And what we did, we solved matrix equation like normal one, right? Well, we just kind of cannot do division. Instead of division, we multiply by inverse, which we actually do in normal equations, right? We multiply by 1 over a, and this is inverse of a actually. So basically, we kind of solve systems of linear equations like we solve normal equations. Okay, and that's going to be all about inverses.